recording now. So as before, please leave after I take the road. All right. And also, we got different problems from time to time. Um, for the internet, especially. I also got the problem today, so that's why it took me a few minutes to log in. But fortunately, I didn't get a huge problem today, we're good now. Yeah, please turn it off. Dwayne, could you please turn it off? Uh, all right. So we got more people joining us. That's good. Let's talk about the quiz and test first. Uh, we we're gonna have the quiz on Wednesday, as I said before. So we don't have class on Wednesday. You just take the quiz as usual from 1 to 1:15. The quiz will cover section 1.3 and 1.4, I think. But I'm gonna send an email and also post in Blackboard. So just check those. And then we're gonna have the second test on next Monday, and that will cover everything after test one and up to today. So everything after test one will be covered. And we also have a class on Friday, but I'm not planning to cover any material on Friday. Instead, I just ask questions for you. So you got a little time to prepare the test. And just answer questions from students on Friday, like before, like last time. But we do have class on Friday. Okay, so that's the plan. Um, I guess some people ask me about makeup, so quiz or test. If you missed any quiz or test, please make them up real quick. If you haven't got the Web of Science set up, then please do it right away after the class. So once you get everything ready, just call my cell phone number, okay? And then I can arrange it for you right away. But they need to get everything ready, including Web of Science. So before you make up, you should log into Web of Science and then call me. Then I just stop the makeup. So that's the plan. We should do it one by one, case by case. All right. So that's about the makeup. Okay. So any questions from your side? Okay, no question. Then it's already 1:10, so we can start the lecture now. We got 16 people right now. I hope more people will join us. So we didn't finish 1.4 last time. I think we were in the last slide. Okay, this is the one we did. You know, we talk about quadratic equations and how to solve quadratic equations. We talk about factoring. You know, we talk about taking the square root. We talk about completing the square. And we have the one last method that can always work. That's the quadratic formula. So if you have a quadratic equation x squared plus bx plus c equal to 0, then you can use the formula x equal to negative e plus or minus square root of b squared over 4ac over 2a to find the answer directly. And you probably have learned it before, so we just do one example using the quadratic formula. So let's just solve the equation as 3x squared plus 2x minus 10. And this turned out to be hard to factor. Of course, you can use the completing square method to solve the equation, but You can use the quadratic formula also, if you want. So just plug in the numbers a, b, and c in the formula. A, b, and c are the coefficients for the leading term x squared, the coefficient for the linear term x, and the constant. Okay, but the one thing to be careful is the signs of the constants. Okay, sometimes they could be positive or negative. Like in this example, a will be 3, b will be 2, and c will be negative 10. All right. So just plug in the numbers in. So we got negative 2 plus or minus square root 2 squared minus 4 times 3 times negative 10 over 2 times 3. All right. And then you just, figure out those numbers. 2 squared is 4, and 4 times 3 is 12. 12 times 10 is negative 120, but then we got another negative sign in the front, so that becomes 4 plus 120. So we got the negative 2 plus square root plus or minus square root 124 over 6. And then you can simplify this a little bit by factoring 124 in the square root as 4 times 31. And then square root of 4 is just 2. So that becomes 2 plus or minus 2 times square root of 31 over 6. And then you can cancel 2 on the top and at the bottom in each term. And then we get negative 1 plus or minus square root of 31 over 3. So that's the answer for this example. Any questions? Okay, one more last thing for this section. We have something called discriminant of the quadratic equation. The discriminant of the quadratic equation is defined as the quantity b squared minus 4ac, and we use delta to denote it. So this is the quantity under the square root in the quadratic formula. The part you need to take square root. Okay, then x will be equal to negative b plus or minus square root delta over 2a. Okay, so then we have different cases. If delta is greater than 0, the discriminant b squared minus 4ac. If it's positive, then you take the square root of the positive number, you get a real number. Then the quadratic formula just tells you you got two distinct real solutions because of plus and minus. If the discriminant delta equals 0, when you take the square root of 0, you get 0. So in the quadratic formula, you get plus or minus 0. So that's essentially doesn't do anything. So you only get one real solution of negative b over 2a. All right, and that's the real solution. Or sometimes it's called a double solution. Two solutions equal to each other. That means. The other case, if the discriminant delta is less than 0, then you try to take the negative number, you're going to get complex solutions. And because of the plus and minus in the formula, quadratic formula, you got two distinct complex solutions. Okay, or the quadratic equation does not have a real solution. Okay. So that's the slide in this section about quadratic equations. All right, any questions about this section? If no question, we just go on to the next section. All right. So section 5. All right. So we're going to talk about the complex numbers in this section. Some basic properties, or some fundamental things, but complex numbers. We just talk about quadratic equations in 1.4, and sometimes we get the complex solutions. That happens when you take the square root of a negative number. So what how is the complex number defined? Okay, so we need to have imaginary unit I defined and to start. So I is defined as the square root of -1. If you take the square on both sides, you get I squared equal to -1. So we're going to use this factor later when we try to handle complex numbers multiplications. Okay. So then any complex number we will include the two parts, the real part and the imaginary part. And it's reading in a form of a plus bi, and that's called the standard form of complex numbers. A is called the real part, and B is called the imaginary part. You get the bi, as complex. Okay, so when b is not equal to 0, the imaginary part is not 0 because the complex number a imaginary number. All right. So -5 plus 3i, and that is -5 plus square root of -9. That's called the imaginary number. All right. So if you draw a diagram between real numbers and the imaginary numbers and the complex numbers, they have this following relationship. So in this diagram, you're going to see real numbers, the set for real numbers represented by the circle, and then we have complex numbers larger than that. So the real numbers are a subset of complex numbers. It's one part of the complex numbers. If you take out the real numbers from the complex numbers, then we got the imaginary numbers. Okay. So those are the numbers with the part of I. All right. Okay, so then how do we handle complex numbers operations with complex numbers? Okay, the rule is this thumb rule is you treat the complex numbers just as a polynomial of degree 1. Okay, just like a plus bx. We got the complex number a plus bi, just treat it as a plus bx. Okay, so that means a and bi, they are not like terms. All right, but there's something we need to be careful, as we will see when we do the multiplication between complex numbers. Right now, let's just talk about addition and subtraction of complex numbers. Just do it as polynomials. So like a 4 plus bi, 7i plus 1 minus 6i. So you can combine the real part and the imaginary part. 4 plus 1. Okay, so that's the real part, and 7i minus 6i, that's the other part. So we got the 5 plus I. 7i minus 6i is just like 1i or I. So you think I just a unit, okay? And similarly, if you add 1 plus 2i with 3 minus 2i, then you get 1 plus 3, you combine 1 plus 1, 3, and 2i, and negative 2i. So you get 4 plus 0i, which is 4. And then you can, do the same as subtractions, like 3 minus negative 2i, 2 plus 3, and minus 2 plus 5i. So distribute the negative signs in each part. You get 3i plus 2, minus 3i minus 2, and minus 5i. Then you just combine all the real parts and all the imaginary parts. So we get 2 minus 2, and we get 3i minus 5i. So we got 0 minus 5y, or just a negative 5y. to do another example, we add 3 plus 2i with 4 minus I and subtract 7 plus I. Again, we distribute negative sign in the third part, and then combine all the real parts and the imaginary parts. So we got 3 plus 2i plus 4 minus I minus 7 minus I, and the combined real parts, we get 3 plus 4 minus 7. And then combine all the imaginary parts, we get 2 minus I minus I. Okay, so if you do the additions, you get 0 for the real part and 0 for the imaginary part. So the answer is just 0. All right? Pretty simple. Okay, multiplication with complex numbers. So this is the part that we need to use the property of I squared equal to negative 1 as we talk about on the first slide. When we define I equal to square root of negative I, then it automatically means I squared is negative 1. Okay, so when we multiply complex numbers, we just do it as if we were doing multiplication of polynomials. So we got 2 times 3 and 2 times 3i and plus negative 4i times 3 and plus negative 4i times 3i. Okay, just expand it or follow it and treating I as just like a variable. Okay, so 2 times 3 is 6 and 2 times 3i is 6i. Negative 4i times 3 is negative 12i, and negative 4i times 3i is negative 12 times I squared. You just multiply the numbers and the numbers together, and the I times I themselves. Okay, like this. And then because I squared equal to negative 1, so we should replace I squared by negative 1 in the last term in this expression. So we got a 6 plus 6i minus 12i minus 12 times negative 1. So that's the only part you need to do extra from the multiplication of polynomials. So that's 6 plus 6i minus 12i plus 12. All right, then you just combine all the real parts and all the complex parts separately. So we get the 6 plus 12 equal to 18, and the 6i minus 12i is negative 6i. All right. Okay, so the other example is 4 plus 5y times 4 minus 5. So again, you just expand it or follow it. So we get 4 times 4 plus 4 times negative 5y plus 5y times 4 plus 5y times negative 5y. 4 times 4 is 16. 4 times negative 5y is negative 20i. 5y times 4 is 20i. So just multiply the numbers, okay? And keep I as it is. And 5y times negative 5y, you get 5 times negative 5, which is negative 25, and I times I, that's I squared. So that's, everything is just like a polynomial multiplication, right? And then again, I squared is negative 1, so we got 16 minus 20i plus 20i minus 25 times negative 1. If you combine those terms, you're going to get, 16 plus 25. And negative 20 and plus 20, they just cancel. So at the end, you got the answer to be 41. So let's do one more example of perfect square. 4 plus 2i squared. So by the square, it means you multiply 4 plus I by itself. So again, you just follow it as what we did before. Okay, so 4 times 4 plus 4 times 2i times 2i times 4 plus 2i times 4 plus 2i times 2i. So 4i times 4 times 4 is 16. 4 minus 4 times 2i is 8i. 2i times 4 is 8i, and 2i times 2i is 4i squared. Okay. Again, I squared is -1, so you just replace I squared by -1. We got 16 plus 8i plus 8i minus 4. I combine the real parts and the imaginary parts, we get 16 minus 4 is 12, and 8i plus 8i is 16i. So the final answer is 12 plus 16i. Good? Any questions about this? Okay, no question, just move to the next page. Okay, the next thing we call complex conjugate. That's an important concept we're going to use quite a bit when we deal with complex numbers, especially when you have complex numbers in the denominator. We need to use a complex conjugate. What is the complex conjugate? You just change the sign of the imaginary part. So like if you have a complex number, a plus bi, then we call it a minus bi, the complex conjugate of a plus bi. And you can also call a plus bi the complex conjugate of a minus bi, conversely. So a plus bi and a minus bi are called the complex conjugate to each other. Okay, so that's the definition. So why do we need a complex conjugate? One of the important properties for complex conjugate is if you multiply a complex number by its complex conjugate, you're going to get a real number. Okay, so let's see how it works out. So let's just multiply a plus bi with a minus bi. Okay, so these are complex conjugate to each other in general. So just to expand it, we got a times a plus a times negative bi plus bi times a plus bi times negative bi, right? A times negative bi, you just multiply a with b and you got negative sign, so we get negative abi. A times a just a squared, and bi times a again just a times b times I. And b times negative bi, you get b times negative b, so you get negative b squared, and I times I just I squared. So again, replace I squared by -1, and then combine like terms. Okay, so we get a squared minus negative abi plus abi minus b squared times -1. So negative abi and positive abi, they just cancel. Okay, remember, those are just the multiplications. Okay, abi and negative abi. And then we got the a squared plus b squared at the end. So so a plus bi times a minus bi equals a squared plus b squared. So we can use that directly. We don't have to do the foiling, from now. Like if you multiply 1 plus I with 1 minus I in the next example, so a is just a 1 and b also is equal 1, right? A plus bi, right? So that's equal to a squared plus b squared. So we got a 1 squared plus 1 squared as the result. So that's just 1 plus 1 or equal to 2. Another example, 4 minus 3i times 4 plus 3i. So this time a equals 4 and b equals -3. So using the formula a plus bi times a minus bi equal to a squared plus b squared. So we got the answer 4 squared plus -3 squared. So we get a 16 plus 9, which is 25. Okay, so the next example is typical and is important. We can use to rewrite a complex number in standard form. So what does it mean by standard form? Remember, it should be like a plus b. You not have anything in the denominator as complex numbers. It should be a real part plus a imaginary part. They're separated. Obviously, in this example, 2 plus I over 2 minus I is not in standard form because you got the 2 minus I in the denominator. You cannot just simply separate a real part and the imaginary part as a plus bi from this form. So what we do is we're going to multiply the complex conjugate of the denominator, okay, both top and at the bottom. So the denominator is 2 minus I. So the complex conjugate is plus 2 plus I. Just change the sign of the imaginary part. So we just multiply 2 plus I over 2 plus I. Okay. Again, 2 minus I times 2 plus I using the formula of complex conjugate multiplication. So we get 2 squared plus negative 1 squared. Okay. A squared plus b squared. Right. And on the top, if you want, you can folio it. So it's 2 times 2 plus 2 times I plus I times 2 plus I times I. So 2 squared is 4 and negative 1 squared is 1. Okay, 2 squared is 4, I'm sorry. 2 times 2 is 4, and then 2 times I is 2i. I times 2 is 2i. I squared, the last term on the top. And that's just negative 1, so we can combine like terms. So we get 4 plus 1 in the denominator is 5. And the 4 minus 1 is 3 on the top, and 2i plus 2i is 4i. So then we can separate the complex number in real and the imaginary parts. So that becomes 305 plus 4i over 5. Right? So that's the final answer. Any questions? Okay. Let's just come back to the complex solutions of quadratic equations. So this is pretty simple, we as we already did before. But let's just review, this square root of negative numbers. So if you have a number a greater than 0, that's positive. So when you take the square root of negative a, you're trying to take the square root of negative number, and that is defined as square root of a times I. Okay, and this is called the principal square root of negative a. Okay, remember when you take the root of any number, you plus or minus, but we choose the plus sign as the principal square root. Okay, so that's the point here. Okay, just do something else using the principal square root of negative a before we go to the next problem with solving quadratic equations. And you can see why we need to define this principal square root of negative a. Okay. So in the following examples, we need to write the complex numbers in standard form. So the first example is to multiply square root of negative 3 and square negative 12. Okay, the way to do it is not to multiply negative 3 and then negative 12 under the square root. That's not the right way to do it. We should use the principal square root to rewrite square root of negative 3 as square root of 3 times I, and the square root of negative 12 as square root of 12 times I. Okay, based on the definition of principal square root. Okay, and then we multiply square root of 3 with square root of 12 as before, and I times I. So we're going to get a square root of 36 if we multiply 3 and 12, and then we get I squared. Square root of 6 is just 6, and I squared is negative 1. So 6 times negative 1, you get the negative 6 as the final answer. Okay, so that's the way to do it. If you multiply -3 with -12 under the square root, you're going to get the square root of 36, which is positive 6. And that you know, differs a sign in the final answer. So you should always follow the standard steps or procedure to rewrite complex numbers by using the principal square root to start. You should not multiply the negative numbers under the square root directly. That's not the way to do it. Okay, just keep in mind this is very tricky. And the next example is square root of -48 minus square root of -27. Again, we use the principal square root. So we get the square root of 48i minus square root of 27i. Okay. So then you just factor 48 by 16 times 3 and 27 by 9 times 3, and then the square root of 16 is 4, so we get 4 times square root of 3i, and square root of 9 is 3, so we get minus 3 square root 3i. So 4 square root 3 minus 3 square root 3 it's just square root 3. Okay, remember? So at the end, the final answer is just square root 3i. Okay, another example. And -1 plus square root -3 squared. Okay. Well, again, you need to rewrite the part in the parentheses, using the principal square root. So square root of -3 is just square root 3 times I. Okay, that's always the way to start. And then multiply -1 plus square root 3i by itself, and for it if you want. So you get -1 times -1 plus -1 times square root 3i plus square root 3i times -1, and then you get the square root 3i times square root 3i at the end. Okay, so -1 times -1 is just 1, and -1 times square root 3i is just negative square root 3i, and the square root 3i times -1 is also negative 3i, and then square root 3i times square root 3i is just square root 3 square. Remember, you multiply square root 3 by itself, and I times I square. So the last term is just 3. Okay, square root 3 square is just 3, and I square is -1. So you get the 3 times -1. So that's -3. Then you just combine the terms. 1 minus 3 is just -2, and the square and negative square root 3 minus square root 3i is just -2 square root 3i, right? We got 2 copies of square root 3i. So that's how you do the square root of negative numbers. Okay, you should always rewrite it as the principal square root to start. Okay, otherwise you make mistakes if you don't. Very easy to make mistakes. Okay, let's just use the complex numbers to solve quadratic equations. So in the next example, we need to solve the quadratic equation 8x squared plus 14x plus 9 equals 0. And you can try to follow it. It turns out it will be hard to do it. So let's just use the quadratic formula, okay, to make it easy. So remember the quadratic formula we just discussed in last section is -b plus or minus square root of b squared minus 4ac over 2 times a. So in this example, a equal to 8, b equal to 14, c equal to 9. Okay, so just plug in those numbers. So we got -14 plus or minus square root of 14 squared minus 4 times 8 times 9 over 2 times 8. And 4 squared is just 196. 4 times 8 is 32. 32 multiplied by 9 is 288. And 2 times 8 is 16 in the denominator. So 196 minus 288 is just negative 92 inside the square root. And then, just use the principal square root to rewrite square root negative 92 as square root 92 times I. Okay. All right, then you can simplify it a little bit by factoring 92 by 4 times 23. Okay. And then square root 4 is 2. So we get the negative 14 plus or minus 2 times square root 23i over 16. And then if you divide by 2 for each term in the numerator and in the denominator, or cancel 2, top and bottom. And then we get the negative 7 plus or minus square root 23i over 8. So divide every number on the top and the bottom by 2. So that's the final answer. Okay. Any questions? So we just got 1.5 finished. We still have 7 more minutes, but I'm not planning to do anything for 7 minutes today. So we got a little time, to answer questions. Any questions about anything? So again, as I said, we have class on Wednesday. You just do the quiz on Wednesday from 1 to 1:15 by yourself, and then we'll meet again online on Friday in the class time. But I'm not going to do any new material on Friday either, and I just answer questions. And then you take test 2 on next Monday. All right. So as I said, quiz, and this will covers material of 1.3 and 1.4. But the test next Monday will cover everything after test 1. Okay, so including today 1.5. So I think basically everything in chapter 1, right? I think actually we got one section in the preliminary chapter P6, which also will be included in the test, I think. That was not in test 1, so it will be in test 2. But read my emails about it, and I will also post it in Blackboard announcement about the test. Any questions? Okay, if no question, let me just take the roll, and then you can leave. Okay, so I got the row, and you can leave now. If you don't have any questions, I'm going to turn off the recording.
So, do we got a midterm for this class?
We do not have another midterm. We just have test 2.
All right.
And then the midterm grade will be based on essentially all the tests and quizzes at this point. So we don't have anything like a midterm exam, no.
All right. When the grades can be posted? Because I still don't see no grade for this class.
Right. The grade, the midterm grade will be posted on Wednesday. I think that's the deadline to post it. So you should be able to see midterm grade on next Wednesday.
All right.
Okay. Any other questions? So let me just turn off the recording.